So here we need to resolve the given rational fraction into its constituent partial fraction. Let us begin. So we are given the rational fraction 2x minus 1. So we're going to suppose that let this rational fraction 2x minus 1 divided by x plus 1 times x squared plus 2 can be broken down into, say, two partial fractions, because here we have two factors, one being x plus 1, the other being x squared plus 2. So our first partial fraction will be a over x plus 1 plus the next partial fraction. So it's not going to be b over x squared plus 2, but because x squared plus 2 is a quadratic factor. So here we'll have to consider bx plus c. Okay, so our goal will be to determine the value of a, b, and c, and upon doing that, we'll be able to resolve the given rational fraction into its partial fraction. We're going to label this as number 1. So let's do one thing. So we're going to take equation number 1 and multiply throughout with x plus 1 times x squared plus 2, such that we get 2x minus 1 equals to x squared plus 2 times a plus x plus 1 multiplied to bx plus c. So let this be number 2. Then in the next step, what we'll do, we'll take 2x minus 1 equals to, what we're going to do, we're going to simplify the expression on the right hand side of equation number 2 and combine all the like terms. So here we'll have x squared, so it will have the coefficient a plus b added to x, so the coefficient of x will be b plus c, and we have the constant term 2a plus c. The reason why we're writing in this particular fashion, that means we are considering the coefficient of x squared and x, because here on the left hand side we have a coefficient of x, so that's 2, but we don't have any coefficient of x squared, so we can also rewrite it as 0 times x squared, would mean exactly the same thing. Now in doing so, what we can do, we can, let's label this as number 3, we can equate both sides of 3. So let's equate both sides of 3. So this is going to give us a plus b. So that's the coefficient of x squared on the right hand side. This will be equals to the coefficient of x squared on the left hand side, which is simply 0. Then we have b plus c. That's the coefficient of x. This will be equals to the coefficient of x, which is 2. And then we have the constant term 2 a plus c. So it is going to be equals to negative 1. So we have 3 unknown parameters a, b, and c, and we got 3 equations. We can solve these 3 equations to obtain the value of a, b, and c. Okay, fine. So we can do one thing. So let's label these as equation number 4, number 5, and number 6. Fine. So now let's do one thing. Let's take equation number 4, and from it we are going to subtract equation number 5. So that's going to give us a plus, so here we have a plus b, so b minus b will go away, so we have negative c. A minus c, this will be equals to 0 minus 2, so that's going to be negative 2. Then we're going to take equation number 6 and keep it as it is, so that's 2a plus c equals to negative 1. Now what we'll do, we'll add this new 2 equation. So on adding, we have 2a plus a, so that's 3a. Plus c and negative c, that cancels out. Then we have negative 2, negative 1, so that's negative 3. So solving for a, we get a equals to negative 1. Fine. Now what we can do, we can use the value of a and substitute this in equation number 4. The equation number 4 will be negative 1 plus b equals to 0. So solving for b, we get b equals to positive 1. And then we can go to equation number 5. The equation number 5 where b plus c equals to 2, that means we have 1 plus c equals to 2. Solving for c, we get c equals to 1. So we have now obtained the value of a, b, and c. So let's go back to equation number 1, which is our partial fraction. So we had 2x minus 1 divided by x plus 1 multiplied to x squared plus 2. So this will be equals to a over x plus 1. So we have negative 1 divided by x plus 1 added to bx, so that's going to be simply x. So we have x plus c, so c is 1, divided by x squared plus 2. And this is going to be the required partial fraction. That means we have successfully resolved the given rational fraction into its constituent partial fraction, where one of the partial fraction is negative 1 over x plus 1 and the other being x plus 1 over x squared plus 2.